Hello, this is Zahar Hilkevich, and today we're going to solve a new puzzle. I would call it a row duplication puzzle. Suppose that we have, let's say we have a table with the following content on a screen with three columns: ID, name, and times. ID is just a unique identifier, name supposed to be unique as well, and times points to the number of duplicate rows that we want to generate. So we need a query that would return value A just once, value B twice, and value C three times. Let's look at the first thing that usually comes to my mind when I see a problem like that. So we'll apparently need two copies of the table, and here I created a table called data table with this content. So again, we'll start with the from clause. There will be data table A, join data table alias B on. Well, one thing that we should try is this. Let's say A ID should be greater or equal than B times, and we'll select everything from A. Sort by ID column. So it looks like we achieved what we wanted, but here a strong assumption was made. Specifically, ID column matches times. And let's say if C had times value 4 or 5, it wouldn't work unless it matches ID column. To illustrate this point, let's add one more row to our table. And let's retry this query. Now you can see that D is returned just 3 times instead of 5. So there is something wrong with the approach. So let's try a different one. What if we only had one row in a table? Let's say it's D and times number is 5. Then the problem would be trivial, right? We could have had something like that. Let's select just one row. So if we had something like this, right? Then the problem would be trivial. We would be selecting from X and use connect by. Standard technique for producing a range. Level less or equal than X times. So it works, right? So how could we do the same if we have multiple records in a data table? Well, when I see something like that, it usually rings a bell to use lateral views. So let's see how this works. So we will be selecting content of data table with alias A, and we will make a join to lateral view. And essentially, a lateral view is a view that has a reference to all other tables on the left side. So here, it doesn't matter what we're going to select. We can even select null. what matters is how many rows we're going to select, because instance A and lateral view will form Cartesian product, so number of rows will be multiplied. So we'll be selecting from dual, and techniques that we've already seen here. So level, or you can use row num if you like, should be smaller or equal than A times. Let's see how it works. Connect by. Alright, it did actually work. A returned just once, B twice, C 3 times, and D 5 times. So what we did is we implemented the first query that I showed you a few seconds ago and made it work for the entire data table. So that's how lateral view works. It has a reference to table A. And you can't really do it in a join, at least in a simple way. So that's our first approach, first strategy. The second strategy will be we'll use a similar concept. We will be comparing times column from two different instances of data table. And actually we don't even need that. We can just build something like that, but this set should be big enough to work with all possible values in the times column. How can we do that? So let's start with preparation. We'll be selecting row num, and the value here should be a maximum value in times column from data table. So let's see what it gives us. Okay, got a range from 1 to 5. That should work. So we'll put it in a common table expression. And now, instead of having two copies of the data table, we can use data table and X. So we'll be selecting everything from data table. And we'll join it with X on A times should be greater or equal than X row number. And let's sort it by ID column. And again, it works perfectly as a charm. So that's strategy number 2. Alright, what else? Well, every time you use connect by, you should also consider using recursive common table expression. So here's how you can do it. So we'll define our common table expression X with all the columns from our table. And we will also add one more column that will count number of iteration in our recursion. So we'll be selecting all the columns from our table. And n will be 1, that's iteration number 1. And in case if we had any records with times equal to 0, let's filter them out. So we'll put times greater or equal than 1. Then to make it a legal recursive CDE, we have to use union all with selection from X. So we'll be selecting absolutely the same columns here, and n should be increased by 1. What should be in a where clause? Same thing, but instead of 1 here, we will put n plus 1. Okay, so this will iterate until number of iteration matches times. So the following iteration will fail, and it will be an exit condition from our recursion. So now we're selecting everything from X, and we need to order by ID. And again, everything works just fine. So I hope you enjoyed this video. Please click like, subscribe to the channel, share it, and send me questions, maybe puzzles you want me to review and solve for you. And you can do it in comments, or you can do it in my Facebook group. The link will be provided. Thank you and have a nice day.